In this video, we're going to talk about the derivative of general exponential functions. And so what we know so far is that if I have a function f of x equal to e to the x, the derivative of that function is e to the x again. But what about when the base is not e? So what we're gonna use a fact from chapter 1 way at the beginning of the class. Recall that e to the x and the natural log of x are inverses of each other. So what does that mean? Right, so that means that when I have any number, so like in this case b, I can rewrite it as e to the natural log of b. So the natural log and the e, because they're inverses of each other, they undo each other. Similarly, right, if I have the natural log of e to the b, I also get b. So if I had 5 as the base, then 5 can be rewritten as e to the natural log of 5. And so e and ln, they undo each other, and I will just get 5. So that's what it means to be inverses. So for my function, f of x equals to b to the x, we're going to use this fact that b can be rewritten as e to the natural log of b. So when I have b to the x, I'm going to rewrite this as e to the natural log of b and then to the x. You with me? So b is equal to e ln of b, so I'm just replacing the b with e to the ln of b because this is still equal to b, and so I still have b to the x. And why am I doing that? Well, I know that the derivative of e to the x is e to the x, and with the chain rule, I also know that e to the stuff, right? So if my function is e to the something, so I've been using my very technical notation of stuff, then the derivative is e to the stuff. You get the exponential back times the derivative of the stuff by the chain rule. So here, now I can say my f of x is e to the ln of bx. Right? So I have e to the stuff. So what is the derivative? By the chain rule, this is going to be, I get my exponential back, so I get e to the ln of bx, and then times the derivative of ln of bx. And natural log of b is just a constant, so the derivative with respect to x of a constant times x is just that constant, right? If I had the derivative of 17x, this will just be the constant 17, the coefficient. So my derivative is e to the natural log of bx times the natural log of b. And so this is a rule that we're going to remember. So the derivative of then any exponential is this. Well, I shouldn't have circled it yet. What we want to remember is that f prime of x is then b to the x. You get the exponential back times the natural log of the base. So that's the one that I want to box up. So let's try an example. Let's find the derivative of f of x equals 5 to the x and f of x equals 3 to the, oh, we have stuff. So one is going to use the chain rule and the other one is not. We're just going to use the standard. So this is our exponential general formula for the derivative. So for this one, for f of x equals 5 to the x, what is f prime of x? According to our formula here, the derivative of b to the x, we get the exponential back, so it will be 5 to the x times the natural log of the base, natural log of b. What's b here? b is 5, so times the natural log of 5, and this is my derivative. Now for the second one, I have 3 to the stuff. So this is going to be f of x equals 3 to the square root of x plus sine x. So I don't have just 3 to the x, right? So big if if my f of x was just 3 to the x, what will be the derivative? F prime of x will be, you get the exponential back, so it will be 3 to the x times the natural log of 3. But now that's not just x, I have a function in there. So this is a composition, right? I don't have just x, so that means this function has been composed with something else. So that means we need the chain rule. So what is our derivative then going to be? So f of x, let me just rewrite it. 3, it will be x to the 1/2 plus sine x, right? Because I need to take the derivative of that. So f prime, then using the chain rule, I know the derivative of b to the x, when I have b to the something, is I always get the exponential back. So I'm going to get my exponential back times the natural log of the base. So here I'm going to get my exponential back. So I'm going to get 3 to the x to the 1/2 plus sine x. So I get my entire exponential back times, the base is not e, is 3, so times the natural log of the base. But I also now need, because that's not just x, I need to do times the derivative of the stuff, the derivative of the exponent, and this is by chain rule. Because I have a composition of functions. How do I know I have a composition of functions? It's not just x, right? It's not just 3 to the x. And this big if was just 3 to the x, there's no composition here. As soon as I see that I have 3 to the something other than just x, there's a composition of functions that happen there. So let's finish this derivative. So my f prime then is my exponential, 3 to the root x plus sine x, right? 3 to that entire exponent times the natural log of the base times the derivative of that. So I'm going to use parentheses because I have two terms. The derivative of x to the 1/2 is 1/2 x to the negative 1/2, and the derivative of sine x is cosine x. And that will be my final answer. I don't think there's much you can do to simplify, so I will just write it like that. So let's try an example of finding an equation of a tangent line. Let's do this one. Find an equation of the line tangent to f of x equals 2 to the x times sine x at x equals pi. So one of the things is we need to find the point. So go ahead and find the y value, right? This is f of x is just a fancy name for y. So this is y equals 2x sine x. So when x is pi, what's y? So y will be 2 to the pi times sine of pi. Well, this was nice. Sine of pi is 0, so that means y is just 0. So my point is x is pi and y is 0. Why do I need the point? Well, my task is to find an equation of the line tangent to blah blah blah. So I need to find the equation of a line, so that means I need to be able to put it in the point slope form. Y minus y1 equals mx minus x1. And so that's why I need the point, right? So this is then my x1, y1. That's the point we need. And now we need the slope. How do you find the slope for a tangent line? The slope is given by the derivative evaluated at that point. So at x equals pi. So let's go ahead and find the derivative. So let's note our function. Our function is f of x equals 2 to the x times sine x. So let's put that in here. So f of x is equal to 2 to the x times sine x. So that's a hint. Why is that a hint? The times means we need to use what rule? Right, use the product rule. And so my derivative then is the product rule. So product rule says the derivative of the first, so I'm going to do the derivative with respect to x of 2 to the x times the second left alone plus, Now the first left alone times the derivative of the second. Are there any chain rules involved here? No, right? Everything is to the just x. So 2 to the just x, sine of just x. I recognize a chain rule if it's not just a single x in there. So here, let's write out what the derivative is. The derivative of 2 to the x, so that is like b to the x, right? So then this will be 2 to the x times the natural log of the base. So that's my derivative of 2 to the x. And then times sine x plus 2 to the x times the derivative of sine x. The derivative of sine x is cosine x. And now we need to evaluate this at pi. So our slope at pi becomes m is equal to f prime of pi. So plug in your pi. So I'm going to have 2 to the pi times the natural log of b times sine of pi plus 2 to the pi times cosine of pi. And let's evaluate those. So the nice thing about this is we already know sine of pi is 0. And since everything is being multiplied, so 2 to the pi times the natural log of, oops, I put natural log of b. That should have been natural log of 2. My base is 2. And so you have 2 to the pi times natural log of 2 times 0. So this whole quantity is 0. So I have 0 plus 2 to the pi. And what's cosine of pi? Cosine of pi is equal to -1. So I'm going to have 2 to the pi times -1. So our slope is -2 to the pi. So putting it all together, right, on our point slope form, y minus y1 equals m x minus x1 with m equals -2 to the pi, and the point being x was pi and y was 0. This becomes y minus 0 equals m, so -2 to the pi. Make sure that it is clear that pi is in the exponent, and then times x minus x1, so x minus pi. And this one is easier to put in y equals mx plus b form, so just distribute your slope. So -2 to the pi x, and then minus times a minus becomes plus pi times 2 to the pi. Don't worry about turning that into a decimal. I prefer the mixed form. It's more exact. Okay, so that is an example of finding equations of tangent lines with general exponentials. And in this case, I wanted to do one that requires the product rule. Now, if this had some sort of chain rule in there, it would have been a little more difficult, right? So like for example, I'm going to add an extra example here. If I had f of x equals, like, say, what, 3 to the sine x and then times cosine of x squared plus 1. Now this requires you to do what? You have to do the product rule because of that. And then each of those has a chain rule, because it's not just x, right? It's not just 3 to the x, it's not just cosine of x. So when you see that you have a function and it's not just x on the inside, that means that you have a chain rule going on there. So to summarize our derivatives, let me create two tables, one of our derivatives without a chain rule and then another one with the chain rule. So some of the things that we have learned so far is the general power rule, right? So if you have something that looks like x to the n, then the derivative is, in this case, n times x to the n minus 1. And then we know that e to the x, the derivative is e to the x. E to the kx, the derivative is k e to the kx. You always get the exponential back. And now to add to these, we have b to the x. When the base is not e, you get the exponential back, so b to the x times the natural log of b. And then we have all of our trig functions. So what do we have? We have sine x, the derivative is cosine x. We have cosine x, the derivative is negative sine x. Tangent x, the derivative is secant square x. Secant x, the derivative is secant x tangent x, and so on, right? You can find the other two. Now, with the chain rule, what does this become? So let me just do something like this. So with chain rule, that means then it's not just x. So let me create the same sort of table. And so we're going to have your function. So I'm going to say y and y prime in this case, just because you'll see what I'm going to do. So here, instead of just x, it's going to be like f of x to the n, right? The general power rule. So you have a function, so it's not just x. So then the derivative of that will be n times f of x, then to the n minus 1 times the derivative of f, the derivative of the inside by the chain rule. I should write smaller. And then the e is going to be e to the f of x, right? So then that will be the derivative, then will be the exponential back, e to the f of x times f prime of x by the chain rule. And then b to the f of x, it will be, you get the exponential back. So with, even if the base is not e, you always get the exponential back. So it will be b to the f of x times the natural log of b, because now the base is no longer e, and then by chain rule times f prime of x. And then going into our trig functions, right, if you have sine of stuff, so now I'm being actually technical, so sine of f of x, then the derivative of this will be cosine of the inside left alone, f of x, times by chain rule the derivative of that function, and so on. The derivative of cosine of f of x will be negative sine of f of x, right, times f prime. And tangent, same thing. So the derivative of tangent of f of x, the stuff is secant square of the stuff times the derivative of the stuff. And the big one, I think I've made a huge deal in the last two videos about secant and cosecant. When you have secant of f of x, what's the derivative here? What's the big thing to remember? You're going to get secant tangent, so it's secant of f of x, tangent of f of x, and then times the derivative of tangent, times the derivative of f of x. So times f prime of x. I ran out of room there. That's why it looks funky. So those are your derivatives. Try what are our other trig functions. So we have sine, cosine, tangent, secant. We're missing cosecant and cotangent. So on your own, try to write what is the derivative of these two functions look like with the chain rule. So write that out on your own and practice, practice, practice. So make sure that you do the homework, and like I said in a prior video, the homework may not be enough to get really good practice with the chain rule. So go into the ebook or pick up another a calculus book, do the odd problems, because you can check the answers on those. Just try to get enough practice with the chain rule, because the chain rule is huge, is really important. So email me if you have any questions, come to office hours, contact me. This is a huge section, and I want to make sure that we are getting really good at it. All right, contact me if you have any questions.